So I'm going to try to make a review of the reaction rates test, record that for you, so you can be good to go. It says explain the effect of each of the following factors on reaction rates, including why it happens. So higher temperature, faster reaction. If you want to slow down the reaction rate, lower the temperature. Lower temp, slower reaction. It's not enough to know that that's what happens. We have to be able to explain why, and that's very easy to do. Remember your notes that talked about the orientation of the particles had to be oriented correctly, and they had to have enough energy collisions. Okay, so if that's true, if I increase the temp, that causes an increase in the kinetic energy of the particles. And since energy is necessary to make the reaction occur, we know now that the particles have enough energy to react. Okay, concentration, higher concentration, meaning more particles present. Will give us a faster reaction. If we have a lower concentration, meaning less particles present, slower reaction. Okay, the reason that occurs is if I have more particles, more particles will provide for more collision. Oops, that doesn't look very good. For more collisions. And it's all about the collisions. Have energy to make the reaction happen. The particle size, small surface area. Gives me a higher reaction rate because I have more of the material exposed, so I can have more collisions, higher reaction rate. Think about a sugar cube as opposed to a teaspoon of granulated sugar. It's much easier to get the teaspoon to dissolve than the sugar cube. Because the sugar cube, you have to crunch it up first so you can expose more surface area, so you can get it to dissolve. All right, so more surface area. With smaller particles. Provide for more space. For reaction to happen. Okay. Pressure has an effect on reaction rates between gases and only gases. Please know it's only gases. Only gases, only gases. Okay? All right, clear that out and move on to the next part. So let's go on down to catalysts. All right, catalysts are chemicals used to speed up reaction rates. And what effect do catalysts have on the activation energy? Catalysts lower the activation energy, and that's what makes the reaction go faster because there's less energy needed. Lower the activation energy. Okay. Are they consumed? No. They are not used at all during the reaction. What are enzymes? Those are biological catalysts. Those are the catalysts that are necessary for reactions to occur in living organisms. Inhibitors. What does an inhibitor do? An inhibitor blocks the action of the catalyst. Okay, does delta H do catalysts affect the delta H? No. Delta H is the product energy minus the reactant energy the catalyst does not lower either of these quantities. The only thing the catalyst can do is right here. Lower the activation energy of the whole reaction. Has nothing to do with the energy of the product or the energy of the reactant. That's all it can do. All right, so let's move on with that one. Okay, number 4 says calcium carbonate is added to a solution of sulfuric acid. Explain or list a set of conditions that would make this reaction go as quickly as possible. Well, the acid needs to eat away the calcium carbonate, so I want to increase the concentration of the acid if I want to speed it up. And sometimes that's not a good idea because it could be dangerous, so we could make sure that calcium carbonate was powdered, so we could grind up the calcium carbonate. We could also do something like increase the temperature. Okay. Explain or list a set of conditions that would make this reaction go as slowly as possible. Okay. So our calcium carbonate could just be in chunks. We could have dilute acid. Sulfuric acid is H2SO4. And we could cool off or lower the temperature. One thing that would not change the rate of this reaction, pressure changes would not affect reaction rates because none of these are gases. All right, and we're going to move on. Number 5. Okay, number 5 says hydrogen gas and oxygen gas react to make water. H2 plus O2 gives me H2O. There's 2 there and 2 there. Explain or list a set of conditions that would make this go as quickly as possible. Increase pressure, because they're gases. Would be one thing you could do. You could increase the temperature. I want it to go as slow as possible. I'm going to decrease the pressure. And I would lower the temperature. Okay, number 6 says, what does activation energy mean? And the best thing to say is it's the amount of energy necessary for a reaction between particles to occur. What symbol do we use to indicate the energy of a reaction? We use a delta H. Explain how to calculate activation energy and delta H. So let me move on down so I can have a little more room to write. There we go. Okay. So how to calculate delta activation energy? And I say that activation energy is equal to the energy of the activated complex and the activated complex is these little hills down here on these side bends. Energy of the activated complex minus energy of the reactant. So that. So in this case, it looks like it's about 65 kilojoules. And this looks like 20 kilojoules, so the activation energy is going to be 45 kilojoules. All right, delta H, that's going to be the energy of the products minus energy of the reactants. It's always products minus reactants. Energy of reactants. All right, I'm going to end this recording, and then I'll make another one for the back side.